Hello, welcome to the Space Experiments Laboratory, where we have a breadboard of the light microscopy modules set up. The breadboard is a great facility. It's easy to work on. We can do optical characterizations of the confocal add-on and the upgraded cameras and the whole ball of wax in an easy environment. Why don't you come inside and see the equipment? The Space Experiments Laboratory is part of the Zero Gravity Facility. Zero Gravity Facility is a subterranean drop tower which gives you about 5 seconds of high quality microgravity environment. I suspect, however, that you're interested in a lot more than that, and that's where the space station, the fluids and combustion facility can give you days, weeks, even months of microgravity. Little plug for ASGSR. So let's talk about the LMM enhancements that we've been working on. They're slated for flight in 2016. And last year you saw it set up in the GIU rack in a different building that is a more flight-like configuration. But this year we have it configured on the breadboard microscope that is more amenable to taking optical characterizations, measuring the point spread function, looking at the depth of field and how a particular PI sample looks with the unit. So we have the engineering model confocal unit attached to the top port of the microscope, and the engineering unit gives you the standard interfaces that we've changed around to work better with the flight hardware. We have a high-resolution digital camera, 2K by 2K pixels with a 14 pixel bit depth, and a second similar camera is attached for wide field fluorescence imaging if you would like to use that as well. So as you know, the confocal capability brings finer 3D sectioning to the table with higher contrast and the ability to look deeper into a more turbid sample. But remember that in addition to the 3D sectioning, the 2D imaging is also much better with higher contrast and allows you to look just with a single image deeper into the sample. Otherwise you might have a lot of scatter or flare reducing your contrast. The last thing we want to point out is the laser illuminator that's coupled here with the single mode optical fiber, and we'll go around the table and look at that on the other side. So here we have the neodymium YAG laser package, which couples over 60 milliwatts of 532 nanometer light to the confocal head via this single mode optical fiber. You see the green laser light on the wall. Note that it's important that your samples have a fluorophore that couples efficiently to 532 nanometers, which works well with the filters that are in the confocal head. So in addition to the laser head with a frequency doubling crystal, we have an attenuator which will bring the power potentially down to some tens of microwatts to avoid any photo bleaching or saturation of your sample, and a power measurement fiber as well as the main output fiber coupling. The package also has power conditioning, control and command interface, and cooling, of course. The whole box resides on the back of the fur rack to avoid taking up space that the microscope needs. And the other component here is a command and control computer which emulates the ground to station communication interfaces, which we use here for testing on the ground. So we look forward to seeing your samples and looking at them on the confocal system.